In this video, I'm gonna explain how to perform bending of this cylinder, how to simulate the bending of this cylinder. In earlier videos, I have uh, explained how to simulate the compression of this air-filled cylindrical cell. In this video, I will be explaining how to bend this cylinder by applying a load parallel to this face, this top plate. Okay, let me demonstrate it very clearly. Before that, let's do something. Let's clear which are not needed. I don't need this buckling model right now for this purpose. And right click on dynamic model, which I will be editing right now. Right click on that and edit keywords. Okay, now edit keyword. Okay, click on discard all edits. Okay, so click OK. Now it is said that one more thing, let's see, edit attribute, and things are okay. Okay, great. So now let's go to load module, create a load, deactivate this, or I can delete this. I don't need right now. Okay, let's delete that. Click on create and then select the step 1 if not selected already. Okay, and then select surface traction. I will be applying surface traction over the top face, so click on that, click on continue, select the surface for the load. So let's select the top surface. So I have selected that. Click on done, and then it is asking which side you want, brown or purple. So I want the top outer side, so let's select brown. So this is selected. Now I want to apply journal traction. Click on vector required. It is asking basically the direction of the traction, so I will be applying that traction in the positive z direction. So by specifying 2 points on that direction vector, it will be uh, clear the direction. So let's select this edge is along z direction. So the first point I'm selecting this point, and the second point I'm selecting this point. So now let's see, this is in z direction. Okay, 0 0 1, this is positive z direction. So now this is not. And then next is the magnitude. Give some magnitude, let's say 1000 Pascal. I'm using SI unit, so 1000 Pascal. I have earlier created amplitude, so this is amplitude. Click on OK. So see, now the direction of the traction is shown on the top face. It is in positive z direction. Okay, let's check certain things. Okay, go to step manager and click on explicit. This is the step which we have created earlier. Dynamic explicit analysis will be, and here is the amplitude manager which I have just selected in the load. So this is the step, and you can edit it. I have given this type of amplitude. This is the time, and this is amplitude. This is the load which I have given, that means 1000 Pascal. It will be multiplied by these factors. So this is basically up to 0 to 1, it is linearly, it will increase linearly, and then after, if I continue the analysis up to 3 seconds or 2 seconds, it will be constant. So it is up to your choice, whatever you want. Okay, so click on OK, and then let's check interaction, which I have created earlier for fluid cavity. Okay, so okay, it's okay. Again, let's check in the load module predefined fields. I have created, I think, pressure. Yeah, it is fluid cavity pressure. Okay, good. Let's give some temperature also. Okay, uh, so that, okay, let's click on create others, temperature, limit temp, so you can recognize what is what. Temperature. Okay, select a reason for the field of pressure. Okay, now I have defined the fluid cavity using this point, so click on done. So let's magnitude in SI units, temperature magnitude. So I am giving 300 Kelvin. So basically it is somewhere around room temperature. Okay, let's do that. Okay, I think now we are ready to go to job module. Okay, this is not needed, but Luminous is not needed, so please delete it and let's submit it. Let's wait for results. Okay,